Okay, so for lesson 3, we want to look at solving systems of equations algebraically. And for that, we want to first start with reviewing what we did in Math 10. So in Math 10, we looked at solving linear systems algebraically. So for this first linear equation, which we know is linear, of course, because they're both in the form of y equals mx plus b, or they're not written in that form presently, but we know that the degree of these variables are both 1, so we know that this is a linear equation. So for the first thing we want to do when we solve by substitution, we're going to look at two methods, substitution and elimination. So when we look at substitution, what we want to do is we want to find the coefficient of 1. We want to isolate that variable. Okay, so we'll look for the coefficient equals to 1. Okay, and we want to isolate that variable. So for this second equation, we can see that we've got y is equal to a negative 4x plus 24 if we rewrite that second equation. So we're going to take the first equation, number 1, which is 2x minus 3y, which is equal to negative 2. And where we should have a y, we're going to substitute in negative 4x plus 24. Now, of course, we've now got one variable in our equation. And so what we're going to do there is solve for x. So we've got a 2x plus 12x minus 72 is equal to negative 2. And we've got a 14x. We'll take this negative 72. We'll move that over. That's a plus 72. And when we divide both sides by 14, we now have x is equal to 5. So we've just solved for x. But of course, in any of these systems, we want to solve for both x and y. We're looking for the point of intersection. So of course, we go back to this third equation that we've created, equation number 3, and we know that y is equal to negative 4x plus 24. So y is negative 4 times 5 plus 24. And y is equal to 4. So our solution is 5, 4. Okay, so that's the method of substitution. And the method of elimination means we would line up our variables and we would have to create the same coefficients. So in order to do that, when I look at these two equations up above, we've got a 2x minus 3y equals negative 2, and we've got a 4x plus y equals 24. So I'm going to do this in two separate ways. The first way I'll do this is to eliminate our x's. So in order to eliminate the x's, let's just rewrite this here. Eliminate x. So there are literally infinite ways to use our elimination. And what I mean by that is we can make the coefficients any of the same number. And how would we do that? So if I look at my first equation, I'm going to take equation number 1, and I'm going to multiply it by 2. So what I'll get there is we'll get, if we multiply everything by 2, we would get 4x minus 6y is equal to negative 4. So I've multiplied every coefficient and constant term by a 2. And if I just line that up with the second equation, we've got a 4x plus y is equal to 24. And I'm going to draw a big line underneath those two equations. And what I'm going to do is I'm going to subtract those equations. I'm going to put a big bracket around here to remind myself that I'm subtracting both equations, every term from each other. And I get a 4x minus 4x is, of course, 0. And negative 6y minus a y is a negative 7y. 24 minus 24 is a negative 28. And then we divide both sides by negative 7. And we get a y is equal to positive 4. And then what we could do is we could go back and we could substitute that y equals 4 into either equation. So I could take the second equation, for example. And if y is 4, then we know that 4x plus 4 is equal to 24, right? Because we had 4x plus y is 24. And so, of course, 4x is equal to 20 when we subtract 4 from both sides. And we divide both sides by 4. And x is 5, which is what we knew our solution should be, because we had the same exact answer when we did substitution. Another way to approach this elimination could have been to eliminate x. Okay, or sorry, y rather. Okay, we just eliminated x, so let's do that. Let's do the same thing but eliminating y. So one possible approach here would have been to take equation 2, for example, and multiply everything through by 3. And if we did that, we would then get, because what would make these y coefficients the same? Okay, if we take equation 2 and multiply it all by 3, we get a 12x plus 3y is equal to 72. And our first equation is 2x minus 3y is equal to negative 2. And now I've got a positive and a negative, so in order to eliminate one of those variables, I'm going to add the equations. Okay? And positive 3y plus a negative 3y is 0. And 12 and 2x makes 14x. That's equal to 70. Dividing both sides by 14. And x is, of course, 5. Sub back into either equation. So I'll take equation 2. And that's 4x plus y equals 24. And if x is 5, we get y is equal to 24 minus 20. And we move over this 20. And our answer, therefore, is 4. So that's what we would have done in Math 10. Okay? And the example down below is similar. We would just have to set up those equations first. But this is, again, a linear review for Math 10. Okay, so let's pop down here and look at the Math 20 type questions. Solving linear quadratic systems. So a quadratic system, linear quadratic has, of course, a variable with a degree of 2. Okay, so this first question says solve the following system of equations and verify your solution. So it doesn't say which method we have to use. So let's try this one using substitution. Okay, in order to use substitution, right away I can see my process. I'm going to solve for my coefficient of 1. And if I take this first equation and rearrange it, we get a 5x minus 10 is equal to positive y. And now I'm going to take that and I'm going to substitute into my second equation, where I've got x squared plus x minus 2 times y is equal to 0. And where I see y, we're just going to sub in the 5x minus 10. And let's distribute. We get an x squared plus x minus 10x plus 20 equals 0. So, of course, x squared minus 9x plus 20 equals 0. And if you'd like to decompose this in order to factor, that would be totally fine. But I recognize right away that I have a coefficient of x squared of 1. My a value is 1. So this can be solved by inspection. We're looking for a product of positive 20 with a sum of negative 9. And if I write out my factors of 20, which are 1 and 20, 2 and 10, or 4 and 5, I can see right away the ones that can add up to 9 are 4 and 5. I need a positive 20 and a negative sum, so both of those have to be negative. So we get an x minus 4 and an x minus 5. So therefore, x is equal to 4 and x is equal to 5. So now I've got the first half of my system, and I need to still solve for y. So when x is 4, y is 5 times 4 minus 10. Using this equation up here, this third equation. So y is 20 minus 10, which is 10. So our first solution is 410. And again, you're using equation 3. Get y is equal to 5 times 5 minus 10. So y is equal to 25 minus 10, which is 15. So our second equation is 5. Our second solution, rather, is 515. And of course, we know from our first lesson that a linear quadratic, we just have some kind of quadratic and some kind of a linear, and we of course have two solutions. So this particular example says to verify our solution. So I won't do this for every single question, but what does the proper check or verify look like? So what we want to do when we solve or do a check, because we have two solutions and two equations, we're going to have to do basically 4 checks. So on an exam, what we would need to do is we would go back to always when we verify or do a check, we go back to the original equations. So I would not use equation 3 in order to do a check. But what I would do is I'd go back to the first and the second equations. So I'm going to check 4 comma 10. And so I'm going to use check my first equation. And we know that we've got a 5x minus y is equal to 10. And on our left-hand side, I'm going to sub in the 4. I'm going to subtract the y, which is 10. So we get 20 minus 10, which is equal to 10. And on our right-hand side, we've got a 10. So something that seems really picky, but is important, is that we conclude our check with the statement, if it is true, that the left side is equal to the right side. Okay? If it is correct, or if it is equal, then we know we've done it all right, and our check is correct. If we were to get an unequal left and right side, we would either have to go back and recheck our check, or recheck our algebra, because we could have made a mistake somewhere. And now let's do the same thing. We are going to check x squared plus x minus 2y, which is equal to 0. We can put a little equal sign there. Okay, so our right-hand side is equal to 0. And our left-hand side, I'm going to substitute in my x and my y again. So we get 4 squared plus 4, subtract 2 times 10, which is 16 plus 4 minus 20, which is of course 0. So again, our left side is equal to our right side. Okay, so we've done the first 2 equations. We've solved and checked 410. Also need to check our second equation, our solution rather, which is 515. So we've got 5x minus y is equal to 10. We set up a little t-bar, and of course the equal sign is what separates the sides. So we're going to sub in 5 times 5 minus 15, and that should equal to 10. 25 subtract 15 is of course equal to 10. So left side equals right side. And again, let's do the final equation. This is kind of a long process, but this is how we would do a proper check. And of course, again, we're going to sub in our 5 squared plus 5 minus 2 times 15, and this should equal to 0. 25 plus 5 minus 30, and that's 30 minus 30, which is equal to 0. So again, our left side is equal to our right side. So there we have it. We've done a proper check with both solutions, both equations, which means we basically have 4 components to our check. Okay? If you would like to try the first equation and the second equation, I can give you those solutions. Okay, if you want to pause the video. For this second equation, it's set up quite nicely for substitution because we already know that y is equal to 4x. You can just pop that in for y. Okay, so if you tried those 2 questions, your solutions should be 0, negative 9, 1, negative 12, and 520 and 1, 4. I would encourage you to try them, it's probably good practice. But if you want to look over your solutions, there's the answers there. Okay, let's try a problem-solving question. It says determine 2 integers such that the sum of the smaller number and twice the larger number is 46. Also, when the square of the smaller number is decreased by 3 times the larger, the result is 93. Create a system of equations and solve the system in order to determine the 2 numbers. So right away, I notice that we are asked to find 2 integers. Okay, so of course, the integer number system, which we denoted by Z in Math 10, includes negatives and positives. But note, there are no decimals, no fractions, etc. So there's the integer number system. So I'm going to watch for decimals in my solutions, and those would be, of course, kicked out. So let's first of all, let's define our 2 integers. It says determine 2 integers at the sum of the smaller and the twice the larger. So I'm going to say let x equal the smaller integer and let y equal the larger integer. I do want to define those variables right away. So let's set up 2 equations. We know that the first equation, the sum of the smaller, which would be x plus 2y, is 46. And when the square of the smaller is decreased by, so we've got our smaller squared, decreased by, so that means subtract 3 times the larger, the result is 93. So this one lends itself quite nicely to substitution because we've got that coefficient of 1 there. So I'm going to take this first equation and I'm just going to rewrite that as x is 46 minus 2y. And now down below here for equation number 2, where I see x, I'm going to substitute in we're going to substitute in 46 minus 2y. Okay, and let's go ahead and expand that. Okay, so to expand that, we know that that's 46 minus 2y times a 46 minus 2y. And if some of you want to use the shortcut, we know that a plus b squared is a squared plus 2ab plus b squared, or a minus b squared is a squared minus 2ab plus b squared. Okay, those are sort of the formulas there. If you want to use that, that's fine. If not, then expand this out using FOIL. Okay, we're just going to distribute those out, and we'll get 46 times 46. I'm just going to pop open my calculator, which is a 2116. Subtract 92y, subtract 92y, plus 4y squared minus 3y equals 93. And when we simplify that a little bit, we get a 4y squared minus 187y minus 93. Sorry, plus a 2023 is equal to 0. Okay, when we move that 93 over, it gets subtracted from the 2116. So now I notice right away I've got a giant set of numbers to factor, and one strategy, because there's nothing we can factor out of there, that 4 will not be a factor of 187. There's no greatest common factor. So one strategy or trick that we can use in a case like this, we could play with the numbers, we could write out all our factors. It might take us a while. One quick way to solve something like this is to use the quadratic formula, sort of as a strategy to factor really large numbers. It's not a bad idea to practice that again. So what we would do here, I know that A is 4, B is negative 187, and C is 2023. So we of course get y is equal to a negative 187, which is positive, plus or minus the square root of 187 squared. And that was a negative, but I often say that if we're going to square that out, we just make it a positive right away. Minus 4 times 4 times 2023, all over 2 times 4. And when we simplify that, we get a plus or minus the square root of 2601 all over 8. And if we plug that 2601 into our calculator, we get 187 plus or minus 51, which is the square root of 2601, all divided by 8. And of course, to solve separately, y is 187 plus 51, all divided by 8, which is, with our calculator, which is equal to 29.75. And our second solution, y is 187 minus 51 divided by 8, and we get y is 17. So one thing I note right away here is that this is not an integer, okay? So that one gets omitted. And so to find our solution here, we're looking for our other value for this solution. We've got the y coordinate, but we need the x coordinate. So I'm going to go back to this equation up here. X is 46 minus 2 times 17. Okay, so x is 46 minus 34, and x is 12. So our final solution is 12, 17. Okay? And if you'd like to try the next question, it says determine two integers that have the following relationships. 14 more than twice the first gives the second. Okay, so as an equation, if I were to define those variables, the first and the second, okay, let's just create our two equations to begin with, part A here. 14 more than twice the first, so I'm going to start with my first. 2 times the first, 14 more than that will equal the second, okay? And we would define our first integer as x and our second integer as y, and we would write that down, okay? Let x equal the first integer. Let y equal the second integer. In the second equation we can come up with here, the second integer increased by 1 is the square of the first. So there are our two equations, okay? And we could, of course, solve that. I can let you to that. One thing I noticed right away here, if we solve for y, we note that this one is already isolated, okay? Y is already isolated. For the second equation here, we can get y is x squared minus 1, right? When we move over, then 1 becomes a negative 1. And so, again, we've got y is x squared minus 1. So we can equate those two equations right away. And we can say that 2x plus 14 is equal to x squared minus 1. And if you want to go ahead and try and solve that as a try, the two solutions that you should end up with would be a 5/24 and a -3/8. And both of those would be accepted because, of course, integers can be negative as well as positive. Okay. Let's look at the last equation. Last question here. It says a cargo plane drops a crate of emergency supplies to workers on the ground. The crate drops freely at first, right, of course, out of a plane, but when the parachute opens, the crate gently hits the ground. The crate's height above the ground, okay, that's crate with an apostrophe S. The crate's height above the ground can be represented by the following equations. So h of x equals -5t squared plus 700 represents the height of the crate during the free fall, and -15t plus 750 represents the height of the crate with the parachute open. So as a quick sketch of that, sort of a rough sketch, I know that the first equation is a parabola, and we're looking at time here, so I know that we're only going to be in the first quadrant. If I just do a quick rough sketch, I know that our parabola has a vertex of 0 and 700. Okay, so when x is 0, y is 700, that's our parabola there. Starting with my let's squeeze that in here. Our y-intercept here is 700, okay? Which is the height when the crate would be released, right? At time 0, the height is 700. And then our other equation here, -15t plus 650, okay? Something like that. Let's just, okay? And of course, what is this intersection point? Okay, well that there, right, this would be 0 and 650, but the flight of the crate starts here at 700, it free falls in the path of a parabola, and then it hits the ground over here somewhere, okay? And we're looking at the path of a linear function. So the black line here is the flight of that crate, okay? The point of intersection is, of course, when the parachute opens. We go from free fall to parachute. Okay. So determine how long after the crate leaves the aircraft does the parachute open. So of course this is time and this is height. So we're just really looking for the x coordinate in this case. So if we look at our two equations, this is a nice substitution because I can see that h is negative 5t squared plus 700, or h is negative 15t plus 650. So substituting one of those in for h, we get negative 5t squared plus 700 is equal to negative 15t plus 650. And when we isolate everything to one side, we get a negative 5t squared plus 15t is plus 50 is equal to 0. And right away I recognize that I can factor out a negative 5 rather. We get t squared minus 3t minus 10, which is equal to 0. And let's just eliminate that negative 5. And the reason we can do that is we're just basically dividing both sides by negative 5. Okay, and 0 divided by negative 5 is still 0. So we're really factoring here t squared minus 3t minus 10. And factors of negative 10 that add up to negative 3, negative 5, and positive 2. So t is equal to 5, and t is equal to negative 2. Now right away, I recognize that I cannot have negative time. So what we're going to do, it's implied in this question because we're in quadrant 1, right? This is quadrant 1. We call that Q1, okay? Sometimes we write that as a Roman numeral. If you want to just quickly review, this would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4, okay? And so how long after the crate leaves the aircraft does the parachute open? After 5, and I would presume that's seconds, okay? It doesn't say, but it's not going to be 5 minutes, okay? This would be time in seconds. It doesn't really say what units we're looking at, does it? But let's presume it's seconds. And then what would be the height? Again, let's presume that's feet. Okay, I guess it doesn't say here. I'm going to say that the time is in seconds. And the height is in feet. It would be whatever units the question should say, okay? What height above the ground is the crate when the parachute opens? So, of course, when t is 5, h is negative 15 times 5 plus 650, which is negative 755. So our height would be equal to 575. Okay? Whatever those units would be, I'm presuming it's feet. It might be meters. Okay. All right, and as a practice here, I would recommend in the assignment booklet that you do a few of the questions. You can, of course, do as many as you would like, but I would recommend sort of at minimum we do number 1, 3A, 4A, 5, and 7. Okay, and I would recommend you do at least 1 or 2 verifies just to make sure that you are setting those up properly, because of course we will have to do that on an exam. Okay, questions? Please do not hesitate to contact me. Thank you.